Module 2, Python Basics. Python Basics Demystified, Data Types and Operators. Python Data Types, 2.1. Understanding Python Data Types. 1. What are data types? Data types define the kind of data that a variable can hold in Python. They play a crucial role in how we work with and manipulate information. 2. Common data types in Python. Python supports a variety of data types, including integers, floating point numbers, strings, lists, dictionaries, and more. Each has its unique characteristics and uses. 3. Dynamic typing in Python. Python is dynamically typed, which means you don't need to explicitly declare the data type of a variable. Python automatically assigns a suitable data type based on the value you assign to it. This flexibility is one of Python's strengths and makes it a user-friendly language for beginners. Operators in Python, 2.2. Unveiling Python operators. 1. Categories of operators: arithmetic, comparison, logical, bitwise. Python operators can be grouped into several categories, each designed for specific tasks. Arithmetic operators perform mathematical calculations, comparison operators help us compare values, logical operators deal with Boolean values, and bitwise operators work with binary representations of data. 2. How operators enhance Python's power. Operators are fundamental to Python's functionality. They allow us to perform calculations, make decisions, and manipulate data efficiently. Understanding how to use operators is key to harnessing the full power of Python for various applications. Arithmetic operators, 2.2.1. Addition, subtraction, multiplication, division. Arithmetic operators in Python include some of the most fundamental operations in mathematics. These operators are essential for performing calculations and manipulating numerical data. Addition, plus. The addition operator allows you to add two or more numbers together. It's represented by the plus symbol, and it's used extensively in various mathematical and programming scenarios. Subtraction. Subtraction is performed using the minus symbol. It's used for finding the difference between numbers. This operator is invaluable for tasks like calculating changes in values. Multiplication, asterisk. Multiplication is represented by the asterisk symbol. It's used to find the product of two or more numbers. This operator is indispensable in various scientific and financial calculations. Division. The division operator, represented by the forward slash, allows you to divide one number by another. It's a core operator used for many types of proportional calculations and sharing resources. Modulo and exponentiation. In addition to the basic arithmetic operations, Python offers two more advanced operators that are extremely useful. Modulo, percent. The modulo operator calculates the remainder when one number is divided by another. It's denoted by the percent symbol and is often used in tasks like finding multiples or creating repetitive patterns. Exponentiation, asterisk. The exponentiation operator raises a number to a specified power. It's represented by two asterisks, asterisk asterisk, and it's vital for tasks like compounding interest or calculating growth rates. Real-world applications. Understanding arithmetic operators is crucial not just for math but also for real-world applications in various domains. In finance, these operators are used to calculate interest, investment returns, and financial projections. In science, they're employed to model physical processes, analyze data, and simulate experiments. In engineering, arithmetic operators are used for structural analysis, optimization, and design. In computer programming, these operators are fundamental for solving problems, creating algorithms, and building software. Learning how to use these operators effectively will empower you to solve a wide range of practical problems and make informed decisions in your field of interest. Comparison operators, 2.2.2. Evaluating with comparison operators. Equal, not equal, greater than, less than. Comparison operators in Python allow you to compare values and evaluate expressions, making them invaluable for decision-making in your code. Equal, equals smiley face. The equal operator compares if two values are equal. It returns true if they are and false if they are not. It's the backbone of many conditional statements. Not equal, smiley face. The not equal operator checks if two values are not equal. It returns true if they are not and false if they are equal. It's used for negating conditions. Greater than, greater than. This operator checks if the value on the left is greater than the one on the right. It returns true if it is and false if it's not. It's crucial for making comparisons in data analysis and decision-making. Less than, less than. The less than operator evaluates if the value on the left is less than the one on the right. It returns true if it is and false if it's not. It's essential for ordering data and ranking items. Greater or equal, less or equal. In addition to these basic comparison operators, Python provides the following. Greater or equal, greater than smiley face. This operator checks if the value on the left is greater than or equal to the one on the right. It returns true if it is and false if it's not. It's often used for inclusive comparisons. Less or equal, less than smiley face. The less or equal operator evaluates if the value on the left is less than or equal to the one on the right. It returns true if it is and false if it's not. Like the previous operator, it's also used for inclusive comparisons. Crafting meaningful comparisons. Crafting meaningful comparisons is an art in programming. It's not just about using these operators but also about applying them to real-world scenarios. In data analysis, comparison operators help filter and select data based on specific criteria. In decision-making, they are used to determine the best course of action based on conditions. In sorting and searching algorithms, they play a key role in organizing and finding data efficiently. In everyday coding, crafting meaningful comparisons is about making your code intuitive and easy to understand. Understanding these operators and using them effectively is essential for writing code that can make decisions, filter data, and react to changing conditions, which is a fundamental part of programming in Python. Logical operators, 2.2.3. Navigating with logical operators. And, or, not. Logical operators in Python are your navigational tools for decision-making and complex conditions. And, the logical AND operator, represented by AND, returns true if both conditions it connects are true. It's used when you need both conditions to be met for the overall condition to be true. OR, the logical OR operator, represented by OR, returns true if at least one of the conditions it connects is true. It's used when any of the conditions can make the overall condition true. NOT, the logical NOT operator, represented by NOT, negates a condition. It returns the opposite of what the condition evaluates to. It's used for inverting conditions. Building complex conditions. These operators aren't just about basic true or false checks. They enable you to craft intricate conditions by combining multiple subconditions. You can use parentheses to group conditions and establish the order of evaluation. By chaining operators together, you can create complex conditions that reflect the nuanced requirements of your applications. Decision-making made smarter. Logical operators are the foundation of intelligent decision-making in your code. They allow you to define conditions that mimic real-life scenarios. You can react to different situations, make informed choices, and implement dynamic behavior. Whether you're creating chatbots, games, or business applications, these operators help you write code that adapts and responds intelligently. Consider this example: temperature greater than 30 and humidity less than 70. This condition ensures that both temperature is higher than 30 degrees and humidity is lower than 70% for an action to be taken. In a game, you might have a condition like player_health less than equals 0, or ammo_count equals 0. The player either runs out of health or ammo to trigger a game over. When using the NOT operator, think of conditions like NOT user_is_logged_in. This checks if the user is not logged in, enabling access control. Conditional statements, 2.3. Conditional statements in Python. If statements for decision-making. Conditional statements are the heart of decision-making in Python, allowing your code to respond dynamically to different situations. If statements provide the basic framework for decision-making. They evaluate a condition and, if it's true, execute a block of code. If it's false, the code block is skipped. These statements are essential for implementing actions based on specific criteria. For example, you can use an if statement to check if a user is of a certain age and provide age-specific content. elif statements for multiple conditions. Decision-making often involves more than just a binary choice. Python allows you to handle multiple conditions effectively. elif statements, short for else if, provide a way to evaluate multiple conditions in sequence. When one condition is met, the corresponding code block is executed, and the remaining conditions are skipped. These statements enable you to create multi-branching logic. For instance, in a weather app, you can use elif statements to check if it's sunny, rainy, or snowy, and provide different responses for each scenario. Else statements as fallbacks. Not every decision falls neatly into a true or false category. What if none of the conditions are met? That's where else statements come in. The else statement is the fallback option. If none of the preceding conditions is true, the code block associated with else is executed. These statements are important for providing a default action or response. In a simple login system, you might use an else statement to handle unsuccessful login attempts by displaying an error message. Examples. Consider the following if statement: if temperature greater than 30. If the temperature is above 30 degrees, the code block that follows will be executed. It might trigger actions like turning on the air conditioning. Now, imagine an elif statement. elif temperature 20. Hash code for moderate temperature. This elif statement allows you to take different actions based on a range of temperatures. Finally, an else statement can serve as a fallback. Else. Hash code for all other cases. It ensures that if none of the previous conditions are met, a default action is taken. Demo 1. Conditional statements. Hands-on demo. Mastering decision making. In this demonstration, we're going to explore conditional statements and how they help us make decisions in Python. Code example. Weather equals sunny. If weather equals sunny, print, it's a beautiful day. Else, print, pack an umbrella. We've defined a variable weather and set it to sunny. Then, we use an if statement to check if weather equals sunny. If the condition is true, Python will execute the code block that prints, it's a beautiful day. Otherwise, it will print, pack an umbrella. This simple example demonstrates how we can react to different weather conditions and provide appropriate responses in our programs. Loops 2.4. Embracing Python loops. Loops are essential in programming, enabling us to perform repetitive tasks and process data efficiently. In this section, we will delve into two fundamental types of loops: for loops, which are ideal for iterating over sequences, and while loops, which are excellent for repetitive tasks with conditional repetition. We will also discuss the concept of nested loops, which allows us to tackle intricate, multi-layered challenges. For loops for iterating sequences. For loops are used for iterating over a sequence, that can be a list, tuple, string, or other iterable objects. They allow us to perform a set of actions for each item in the sequence. While loops for conditional repetition. While loops are used to repeatedly execute a set of statements as long as a specific condition is true. They are great for situations where you don't know how many iterations are required beforehand. Nested loops for complex tasks. Python allows you to nest loops within other loops. This capability is handy for solving complex problems and working with multi-dimensional data. Loops in programming, building efficiency. Loops are a fundamental concept in programming that enables us to perform repetitive tasks and process data efficiently. They are like the engine of automation in coding, allowing us to carry out numerous operations without having to write the same code repeatedly. For loops, mastering sequence iteration. For loops are the workhorses for iterating over sequences such as lists, tuples, strings, and other iterable objects. They provide an organized and efficient way to execute a set of actions for each item in the sequence. Example 1. Iterating through a list. Fruits equals apple, banana, cherry. For fruit in fruits. Print, fruit. This loop prints each fruit in the list, making it easy to process and display the elements of the sequence. While loops, perfect for conditional repetition. While loops are invaluable when you need to repeatedly execute a set of statements as long as a specific condition is true. They are excellent for situations where you might not know how many iterations are required beforehand, and you want to continue until a certain condition is met. Example 2. Countdown with a while loop. Countdown equals 5. While countdown greater than 0. Print, countdown. Countdown equals 1. This loop counts down from 5 to 1, demonstrating how while loops are used for repetitive tasks. Nested loops, tackling complex challenges. In programming, tasks can become complex, and data may have multiple dimensions. This is where the concept of nested loops comes into play. Nested loops allow us to have loops within other loops, providing the ability to navigate and manipulate multi-layered data structures. Example 3. Printing patterns with nested loops. For I in range, 5. For j in range, I plus 1. Print, asterisk, end equals. Print. This example demonstrates a nested loop that prints a pattern of asterisks, a common use case for nested loops. Loops are at the core of what makes programming powerful and efficient. They enable us to process data, automate tasks, and solve intricate problems in a structured way. In this section, we've delved into the two primary types of loops in Python. For loops, which are perfect for iterating over sequences, and while loops, ideal for repetitive tasks. We've also introduced the concept of nested loops, which allows us to address complex, multi-layered challenges. As we explore more examples and applications, you'll discover the true versatility of loops in Python. Demo 2. Loops. Hands-on demo. Looping magic. Let's put our newfound knowledge of loops into action with this hands-on demonstration. In this example, we have a list of numbers, and we're using a for loop to iterate through each number in the list and print it. This simple example demonstrates how for loops can efficiently handle sequences, making tasks like data processing and iteration a breeze. Numbers equals 1, 2, 3, 4, 5. For number in numbers. Print, number. This is just the beginning of our exploration of loops, and as we delve deeper, you'll discover their incredible versatility in solving a wide range of problems and automating tasks in Python. Functions 2.5. Your Python toolkit. Functions, the workhorses of Python. 1. Functions are the building blocks of Python programming. They are like powerful tools in your toolkit, enabling you to create reusable and modular code. Defining functions for code reusability. Defining functions allows you to encapsulate a set of instructions into a single, named unit. This not only makes your code more organized and readable, but also promotes reusability. Instead of repeating the same code multiple times, you can call a function whenever you need that specific set of actions. Example 1. A simple function. Def greet, name. Return, hello, plus name plus. This function, greet, takes a name as an argument and returns a greeting message. It can be used to greet various people without duplicating code. Functions as building blocks. In complex programs, functions act as the building blocks that create a well-structured and modular design. You can build your codebase by creating functions for specific tasks, making it easier to manage and maintain. Example 3. Using functions for a calculator. Def add, x, y. Return x plus y. Def subtract, x, y. Return x, y. Def multiply, x, y. Return x asterisk y. Def divide, x, y. Return x, y. These functions can be used to create a simple calculator program. Each function handles a specific operation, making the code more organized and extendable. Note: functions are essential in Python and play a key role in writing clean, efficient, and organized code. They are your toolkit for code reusability, allowing you to encapsulate logic and make it available for reuse whenever needed. In this section, we've explored how to define functions, pass arguments, and return values. We've also seen how functions act as building blocks for creating modular and manageable code. As you continue your Python journey, you'll realize the power and versatility functions bring to your coding projects. Demo 3. Functions. Hands-on demo. Unlocking function power. Welcome to our third hands-on demo where we explore the incredible power of functions in Python. In this demonstration, we'll dive into how to define a function and put it to practical use. Def greet, name. Return, hello, plus name plus. Message equals greet, Alice. In our code example, we have defined a simple function named greet. This function takes one argument, name, and returns a greeting message that includes the name. We then call this function with the name Alice and store the returned message in a variable named message. Let's break down the code to understand what's happening. Def greet, name. This line defines the function named greet, and it takes one argument, name. Arguments act as inputs that the function can work with. Return, hello, plus name plus. Inside the function, we use the return statement to specify what the function should give back as output. Here, we create a greeting message by concatenating the string hello with the name argument and message equals greet, Alice. This line calls the greet function with the argument Alice. The function processes this input and returns the message hello, Alice. We store this message in a variable named message. The beauty of functions lies in their reusability. With this simple greet function, we can greet anyone by just changing the input. Functions help us write code that is more efficient, organized, and maintainable. This is just the tip of the iceberg, and as you become more proficient in Python, you'll find functions are your trusty tools for creating complex and efficient programs. Lambda functions, 2.6. The Python shortcut. Introducing anonymous functions. In Python, we have a powerful feature known as lambda functions, which are also called anonymous functions. These functions don't have a name and are created using a compact syntax. Concise syntax for quick tasks. Lambda functions are exceptionally handy for tasks that require a small, one-time function without the need to define a full-fledged named function. Their concise syntax makes them ideal for quick operations. Use cases and versatility. Lambda functions are used in a variety of scenarios, such as sorting, filtering, mapping, and custom transformations. They're especially useful in situations where you need a function as an argument to another function, e.g., in the sorted function. Example, sorting with lambda. Names equals Alice, Bob, Charlie, David. Sorted underscore names equals sorted names, key equals lambda x, len, x. This lambda function sorts the names based on their length, creating a sorted list of names from shortest to longest. As we move forward in this course, these concepts will continue to serve as the building blocks of your Python knowledge, allowing you to tackle more complex problems, create practical applications, and become a proficient Python programmer. So, let's move on and explore even more exciting Python concepts in the upcoming modules.